Hello and welcome back. In today's session we will be discussing another technique of integration called the integration by parts. If I give you an example, like find the integral of ex dx, then you can find that neither x nor ex is close to the derivative of the other. Thus, your substitution can't be used. So in case of a product and you want to integrate and those are not close to each other, you need to employ another technique of integration called the integration by part. And the definition is given by this equation. This equation is originated from the fact that u dot v prime is u prime v plus u v prime. Rearranging the equation yields that u v prime equal to u dot v prime minus u prime v. Okay, now let's integrate both sides in terms of the x. Then the integral of u v prime dx is equal to u dot v minus integral u prime v dx. So this is the formula, and then we just substitute each term. Now how could we make the choice whether x is u or v prime? Always choose the part v prime, because the v prime is going to be integrated to get v, right? So choose the simpler one, and I mean by simpler that the one that gives you the minimum change. Like for instance, if I take v prime ex and I integrated, it gives me ex, the same, right? So there is a minimum change. However, if I took v prime to be x, then v will be something x squared, right, over 2. So we have x squared, so we have a huge change. So always choose v prime, the one that gives you a minimum change once you integrate it. So for this exercise, we can say let u equal x, v prime equal ex. Then if we want to find u prime, it would be 1 v, the integral of ex is ex. So in order to get v from v prime, we integrate both sides. Okay, and simply you can employ the equation. It is u dot v x ex minus the integral u prime v. Okay, 1 ex dx. So it is x ex. So the integral of ex, 1 times ex is ex. Then the integral is ex plus c, or ex minus 1 plus c. Let's take another example. Find the integral of ln x dx. Okay, we got this formula, the integration by part. Okay, because ln x is multiplied by 1, so let u equal to ln x, then u prime equal 1 over x, v is equal, or sorry, v prime equal 1, v is equal to x. Then we employ the formula u dot v x and x minus the integral of u prime v. And the integral of 1 is x plus c. As you can see, the integration by parts makes your integration simpler and easier to be done. It simplifies things. So it is a complex in X, complex function. Then you are changing, you are modifying them to become easier. Alright? And then you employ the formula. Another exercise, okay, the integral of x sine x dx. So let x, okay, u is equal to x, okay, and v prime equal to sine x. Again, don't take v prime equal to x, because if you integrate it, it will become x squared, okay? While if you take it to be u and you derive it, you make it smaller, okay? So always take the derivative, the one that you can make a huge change on it, and the integral that you can make a very small change of it. Okay, you want to simplify things. So u prime equal to 1 and v is equal to the integral of sine is minus cosine, as we know. Okay, this is equal to u dot v. Okay, then u dot v is x minus 7 minus x cosine x minus, okay, u prime v. The integral of sine, okay, u prime v, sorry, this must be minus cosine. Okay, so minus by minus, it's a plus, and the integral of cosine is sine. Alright, now let's take this to be a little bit complicated. Say that I asked you to integrate x squared, okay, cosine x dx. Now you want to say, okay, again, because x squared, I want to make it simpler, okay, let u equal to x squared, u prime is equal to x, v prime equal to cosine x, and v is equal to sine x. The integral of cosine is sine. Then u dot v minus u prime v, okay, x sine x dx. Okay, if you look over this term, it is a product of two parts that are not derivative of each other, or not even close to each other, right? It is x and sine x. So here we need to employ again the integration by part as we did here. Okay, it's the same integral of x sine x dx, so it's the same as here. So we need again, if assume we didn't solve this question, then you need to do it again. You need to say let u maybe equal to x, u prime equal to 1, v prime equal to sine x, v equal minus cosine x. You keep this term as it is, minus, okay, and we need to employ the integration per part for this term. It is u prime uv, okay, minus u prime v. Okay, x squared sine x plus x cosine x, okay, minus minus, it becomes plus, minus the integral of cosine, it is sine, okay, plus c. Okay, there is a small mistake here. Okay, the derivative of x squared is 2x. Okay, this is 2x. So we have, okay, uv, okay, minus 2. Alright. So alternatively, because we are employing the integration by parts several times, so x squared, the derivative of x squared is 2x, then the derivative of x is 1, the integral of cosine is sine, and the integral of sine minus cosine. So this side we are making the derivative of it, the other side we are employing the integration. So why to write u prime always? We can use a simpler one. Let's say x squared cosine x dx. Then we can directly put the terms that are to be derived at one side, the terms which you want to integrate at the other side. So x squared, the derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. Cosine of x. So you will end up, once you reach an end of derivative. Okay, so the integral of cosine is sine. Integral of sine is minus cosine. Integral of minus cosine is minus sine. So then I can just multiply, because it's u dot v, it's a multiplication. This would be sum, the other part would be minus, because we have minus and we want to employ another technique of integration, and here we get plus. Okay, so you will end up x squared sine x minus it becomes plus 2x cosine x plus multiplied by minus, it's minus 2 sine x plus c. It is the same as we did here. Okay, so in today's session we discussed the integration by part. Again, the original definition comes from the fact that u dot v prime is equal to u prime v plus u v prime. Okay, and we come up with this definition. Thank you.